6 in chapter 7. So let's stick with me. Let's do this together. All right. So I put the steps over here that we're going to follow. Let's just go ahead and follow the rules that we set here. So we are going to go ahead and put our charges on our elements. Let's go ahead and do that. We know this is a solid. Let's not be lazy. Solid. Let's put that 0 charge on that solid. Okay. Now, let's figure out this guy. We have the bracket system that we're going to do. The bracket system that we're going to do. Let's put it around this polyatomic ion. Now, you told me before that this is going to be a negative right here. This guy right here, this guy right here is going to be a negative. And then you told me there's going to be 3 of them. You told me there's going to be 3 of them from right here. So we're going to say this whole thing is going to be a -3 in the bracket. If that's the case, and then we're going to draw another bracket around this guy, this whole thing is going to be 0 because there was no charge on the whole compound to begin with. So if we're going to say that this whole thing right here was a -3, and let's go ahead and put this one in red so we're not confused. Let's do that. So if we know this was -3, then this whole thing must be 0, and this must be a +3. Cool. I think you're really good with this. I don't think I have to spend more time with that. So let's go ahead and do this one again. This will be a negative. There's 2 of them here. There's -2. This will be a +2. Cool. All right. Now, what are we going to do? Now let's put each reactant in its own line. So let's go ahead and take this one, put it in its own line. Fe0 solid. Its own line. Let's put our arrow straight here in the middle. I don't know what's going to happen here yet. Let's bring this whole guy down. 2Fe 3 plus NO3 3. And let's go ahead and put our arrow here. And then we're going to say that since we used 1 Fe right here, we can only make 1 Fe on this side. Okay, so we're going to make 1 Fe on this side. So let's draw that. 1 Fe on this side. But remember that we had a +2 charge on that. All right, so if we wanted to go ahead and balance this in element, we did that. We can balance it in charge now. If we want to do that, this is a +2. This is a 0 on this side. If we want to make this both equal 0, let's go ahead and add 2 electrons like that. Cool. Let's go ahead and down here we have these 2 Fe's. Let's go ahead and put 2 Fe's from here. 2 Fe, and then we're going to say that's also a 2 plus, and then the garbage, NO3 2, and there's a minus in here. We don't need that. So, are we balanced in element? There's 2 Fe's here, there's 2 Fe's here. We don't really care about this because it's spectating. The negative never changed. You got to be changing your sign when you go across here to matter right now, since we're only doing the half reaction. We're not doing balanced half reaction, just half reaction. So let's go ahead and just forget about these for right now. We don't really need these here. These are spectator ions. Their charge never changed. So let's go ahead and take those away like that. I like that. So are we balanced in element? 2 Fe's goes to 2 Fe's? Yep. Are we balanced in charge? Let's do a little cheat sheet. We got 3 here. We have a +3. But remember, there's 2 of them, so it's going to be a +6 on this side. What about here? We have a +2, but don't forget there's 2 of them. So we're really going to have a +4. 6 to 4. How do we make this equal? We can only add electrons. Let's put 2 electrons on this side. You guys take them right here. +2 electrons on this side. All right. So let's get rid of our cheat sheet here and just look at our equations. Right here, we have this our equation. We have this as another half equation. Which one's my oxidation reaction? Which one's my reduction reaction? Which one reduced its charge across the arrow? 3 plus to 2 plus. This is my reduction reaction. That means this one must be my oxidation reaction. I went from a 0 to a 2 plus, I gained charge. I went from a 3 plus to a 2 plus, I reduced my charge. This is problem number 6 and number 7. You're doing really well, stick with me.